Okay, so this is day 3 of logarithms. We're going to continue with laws of logarithms. So Tuesday, we established these first two laws where both of these expressions equal x, depending on where that x is in the expression. So that's what we had established on Tuesday, and I know for the afternoon class, I wasn't here for that period, so it was from another one of these videos. Now, we did talk a little bit about why that worked yesterday. If you have questions still on any of that, please let me know. But yesterday's lesson, when I was here, we talked about our product rule, our quotient rule, and our power rule for logarithms. And we actually proved why all those things exist using those first two laws. So that's the log laws we've established so far. Now, we're going to use those log laws in order to express these two questions in terms of the log base m of a, the log base m of b, and the log base m of c. So basically, the log of a, b, and c separately. So I'm going to write down this first question on paper, and we'll take a look at how to solve this here. The first question here, we want to be able to split it up into our 3 different logs. And so the first thing I've done is I've split that division into our subtraction of logarithms. So using this law here, we're able to split the division inside the logs into the subtraction of 2 separate logs with the top and the bottom of our fraction. And then this one here will have multiplication inside the log, so I can split that into addition of these 2 logs. So I had an addition for my multiplication and a subtraction for my division. And last but not least, to get it in terms of these 3 things, I don't want the exponents here, so I can use my third rule here and bring that exponent out in front. So bring the 2 out in front, bring the 3 out in front, and we get this expression here. So right off the bat, we use all 3 rules that we talked about yesterday in order to solve this question. Let's take a look at this second one here, but it's going to work out being fairly similar, just with one extra thing in the beginning. So for this one here, first thing I rewrote that root as an exponent of 1/3. And as we've talked about before, that exponent can get written out in front. Now I have a whole bunch of multiplications happening in the argument of the logarithm, so I can split those into the sum of these different logs. And because 1/3 was times all of this log, I've written the 1/3 times all the things that came from that log. Brought the exponents down, so brought the 2 down and got 2/3, brought the 4 down and got 4/3. That 1/3 didn't have any other coefficient multiplied by it, so it's just 1/3. So you could answer the question this way. That is completely fine. It's in terms of these 3 things. Or you could write it all over 3 because they all had a division by 3. So this is legal as well. They're both equal to one another. Both are fine ways to answer that question. Either way is good. Our second question here, instead of splitting up a single log into multiple logs, we're going to take multiple logs and turn them back into just a single log here. So the first question, 4 log base 3 of 2 minus 1/3 log base 3 of 8. Very first thing I did is take the numbers that are out in front and write them in as exponents. So 4 goes on top of the 2, the 1/3 goes on top of the 8, and 2 to the 4 is easy to calculate. We get 16. Now 8 to the power of 1/3, that's the same as the cube root of 8, and the cube root of 8 has to be 2 because 2 cubed gives you 8. So now, right off the bat, we have 2 different logs, same base, they're being subtracted from one another. That's our quotient law, so I can divide my arguments. 16 divided by 2 we get 8. So 16 divided by 2, we get 8. This isn't any sort of logarithm that I'm able to calculate. I don't know what 3 to the, sorry, I should maybe reword that. That's not a log I can calculate without a calculator. I don't know what power of 3 I need to get to 8. And the question didn't ask us to try to evaluate it all. So you don't need a decimal here, even though we've talked about how to do that on a calculator. You just want to express this as a single log. This is a single log. There's only one log. So that is good as your answer. We'll look at part B here as well. Okay, so unlike this one where we had coefficients in front, we had to bring those down for our exponents. These already have the exponents written in, so we can jump right into trying to simplify our subtraction and our addition of logs. And so just one big warning about BEDMAS. Even though BEDMAS, that A comes before the S, does not mean that we always do addition before subtraction. They're on like the same level of BEDMAS, so just move left to right. So we got subtraction here on the left. Let's do the subtraction first. Otherwise, you're trying to deal with a negative log and a plus a log. Not that that's impossible, but it may cause problems if you're not paying attention. So we'll worry about the subtraction first, and I'll turn this into an x cubed over an x times y inside our log. And I didn't touch that addition at all. It's still just hanging out there at the end. This next step, all I did is I simplified what was inside this first log. So I canceled out a power of x on the top and the bottom, or a factor of x, I should say. And leaves us with log base 7 of x cubed. Sorry, I keep wanting to cube it. X squared over y plus log base 7 of y squared. And now you can deal with the addition. So now we can turn it into a multiplication statement inside a log. And we just need to know how to how to cancel things out again. So y squared we're multiplying by, y we're dividing by. I can cancel out a y from the bottom and a y from here, and I would just get left with x squared y. So again, just in case, all we've done is we've canceled out one of these y's with one of these y's. Okay, so this last set of questions, solve the following equations for the given variable. Anytime we see the word solve, that always means we got to find our variable. So be careful with the wording, I guess, of questions. You want to make sure that you know what those important words mean. So solve, factor, evaluate, simplify. Solve means find your variable, even if it doesn't say for the given variable. So we're trying to solve for x here. Well, it might not be obvious where to start here, but I'm hoping after today maybe it helps. Now this right side, we can combine using our product rule. So 10 times 4 gives us 40. And so log base 3 of x equals log base 3 of 40. And that kind of looks the opposite of what we talked yesterday. Yesterday, for some of our proofs, we took the log of both sides because we said that, well, if the left side is equal to the right side, the log of the left side should equal the log of the right side. This is kind of working backwards. If I remove the log of both sides, it also should still be equal. So log base 3 of x and log base 3 of 40, they can only be the same thing if that x equals your 40. Now the second question here, there we go. Log base 8 of x minus log base 8 of 6 equals log base 8 of 14 minus log base 8 of 12. I can do the same thing and combine my logs. So the left side, you could just write it as x divided by 6. You could just write the right side as log base 8 of 14 over 12. I realize this is not the only way you have to do this question, but just like I said yesterday, there is multiple ways to do these sorts of questions. So if you have another idea, perfect. That's okay. See if you get the same answer. Now, I'm doing the same log on both sides, log base 8. So it means my left side argument should equal my right side argument. And I've simplified 14 over 12 to 7 over 6 because they're the same thing. That's our fraction simplified. And now you could even take this a step further. If I have x divided by 6 and I have 7 divided by 6, the only way those two things can be equal is your x has to be 7. And so just like that, we're done. So yeah, using our quotient rule for both sides, removing our logs from both sides, and then removing your denominators from both sides. Or you could think of it, yeah, you're multiplying both sides by 6. So I know that is a really short lesson. I will post the completed version for you. I am going to do it on this paper here because I didn't have a chance to print things off at school with this note. Now, if you have any questions over the weekend, please let me know. You have some class time here to try to get your work done and try to have no math over the weekend. I know some people have family commitments over the weekend, so hopefully that helps. But please let me know if there's any questions or I can share any videos or anything. And I'll see you on Tuesday.